Hi, this is Miss Litton, and this is my wonderful Period 3 class. Say hi. Hi. And we are talking about investigation number 5, photosynthesis, the sinking leaf disc lab. Now, the part that you could vary many things in this lab, but the part that we are going to vary for our lab today is what? What are we varying?
Carbon dioxide.
Yeah, the carbon dioxide in the water. Perfect. Okay. That is your input, right? When you do your diagram, if you look at your diagram right now, we're not writing in our lab books right now, you can do this later. It should say input, and that is the amount of CO2 in the water, either with or without CO2. That's your input, right? Okay? And you only have to draw one beaker. Why do you only have to draw one cup or one beaker? Because you've already said what the two variables are. You're just showing me the setup, the scenario is leaves in there. Don't scratch out, don't worry, I'll talk to you when I go through and check each of your lab notebooks today and we'll talk about it, okay? But you would have a cup with those discs in it, okay? What is your output for this lab? What is your dependent variable? Number of discs that are floating, you know, per unit time, right? That's your output, that's your dependent variable. Okay, we're not changing it right now, but we'll talk about it. If we wanted to vary something else, if we wanted a different independent variable, what would be an example of a different independent variable besides the concentration of CO2 in the water? Give me another one.
Light. Distance.
Light. Distance from the light. What else? Could be type of plant that we used. What else? Yes.
Size of the disc.
Size of the disc. Okay. What else could we vary? Type, color of light, right? Temperature. These are all things that we could use to vary in our experiment, but our independent variable will be the concentration of the CO2, either no CO2 or we're going to make a 2% solution. To do this simply, okay, we're not going to use molarity or that, we're just going to do, if I wanted 2%, it's 98 mils of water and 2 grams of baking soda. So what do you have at your lab station in order to do that? You have a balance. Period 1 brought it down for you. You're going to put it back when you're done. You're going to wrap up the cord around here. This right here is going to be set on it, and this is going to sit on top of that, and then it goes on the top shelf when you're done. When they put in these sockets over here, they did not do a good job putting them in. Plug into the one that has the light on it, okay? And do you see how this one has a dot on it? Use that dot, okay? That way, if we all use the dot, we won't blow the circuits, okay? I know, it's sad. Okay, so how do we go about doing this? You have a hole puncher. Your hole puncher is probably in your box of fun. The box of fun is the thing that has highlighters and pencils and scissors and rulers in it, okay? You're gonna take your hole punch and you're gonna punch out from spinach. Pick a nice leaf or two, you know, one that doesn't look all wilty or whatever. Pick your freshest looking leaf out of here. I would rinse it off, make sure there's no dust on it, and then dry it a little bit so it makes it easier to punch. And I would take a white paper towel, set it down, and you want to have about 13 discs each, okay? 13 discs each that you punch out. The reason is not all of them are going to get the sinking ability. I mean, they might. Sometimes it does work out that way. So that way you want to have a little bit of extra in there. Okay, now you want to get the whole disc, not part of a disc, so make sure it gets all the way in there. Try not to get any veins when you do it. Try to get just pure leaf. And dig down in here, because the ones on top are wilty, so dig down in the bottom in order to get your little punches, okay? Will you punch like a few for me so I can model how to do that? Thank you, Madia. Okay, so when you do it, you have 2 syringes that you're gonna use and punch out those 12 to 13 discs, pop open the syringe and put them in there. Then what you're gonna do is you're gonna put the top on the syringe back out and you're gonna push most of the air out. Careful not to smush them, because what you're worried about is maybe disturbing the membranes themselves that are inside. Now, you'll see right here, I have labeled this one without. And I would then put a piece of green tape on this one so that it matched. I don't have to write without on it. I know green goes with green, or you can write without. I have color tape up here, but you have color tape at your lab stations as well. try to use as little tape as possible. Now for you, your water is going to come out of here, but because I'm just modeling this for you, I'm just going to put it in here for my without. And I would very carefully measure how many mils of water. Well, this is without, so 100, yeah. Okay, then what I would do is I would take my 13 discs and I would just drop them in here. Careful not to like smush them too badly. Tap them down in there. And then I go ahead and push this down as close as I can because I don't want to have as much, very much air. Now besides water, water with CO2, water without CO2, what else needs to go into this beaker? Yeah, and you want to keep that number the same, and you don't want it bubbly soap, okay, because that will cause a problem too. You just want to put like your 1, 2, 3 drops in there. If you accidentally put 4, that's going to be fine. Just put how many in the other one? 4, right? Because you're going to keep it as a what? Constant. Perfect. Okay, now I would be mimicking this with the baking soda at the same time. Does that make sense? Okay, then all I need to do is draw up how much water? Do you remember? Not 98. You know how much? 5 mils. Okay, so draw up about 5 mils of water. Now, why are we drawing water up into this syringe? What am I trying to create in here? Vacuum. And the reason is those leaf discs, they have air, space in here. And I want to replace this air with what? Water, so they will what? Sink. Now, as they do photosynthesis, okay, they're going to be needing to use what gas? Carbon dioxide. What's providing the carbon dioxide? Baking soda. So if I don't add any extra baking soda, then that one has no addition of any what? CO2, right? And then when they do photosynthesis, they're going to need CO2, they're going to need water, and they're going to need light. And what is the product from that? Oxygen and sugars. Okay? The oxygen should then start to refill those spaces, which makes the leaf float. So I am able to infer from my data how well my photosynthesis is going on by how many of those leaf discs float and how long it takes them to float. Right? Turn towards your bio buddy. Ask him, you got any questions so far? So, if I want to figure that out, I've got to carefully make a vacuum in here. You only have so many times to do this. Because after about 3 snaps, okay, you will come to find out after about 3 snaps, it'll start to destroy the membranes. If the membranes are destroyed, you're not going to be doing any what? Photosynthesis. So you want to do well at it right away. Okay? So what you end up doing is you take your solution, okay? I just sucked it up, but there might be air here, so it's not going to create a vacuum. So what I need to do is push all the air out. My leaves won't come out. Does it look like just water? Oh, look, there's just water. So I'm good. Okay? Then I put my thumb over here, and I put my fingers here, and I push hard. So I can feel it into my thumb right now, okay? Now I pull back to 10 while I'm shimmy, shimmy, Cocoa Puff shaking. Make sure they're all surrounded by that water, and then I let go. Okay? Now, when I let go, that should help to make them sink, to create that vacuum. Now, give it a second. Just set it down and, like, tap it. Last class, they all sunk on the first go. It was super awesome. Doesn't look like it's going to work out like that for you, though. So, but they are, do you see that they're starting to sink? So what you want to do is give it a second, because you might think, oh, I didn't do a good job. Just flick them a few times, and I'm like, hey, I'm getting them to sink, okay? And you could be doing your other one at the same time. Now, if they don't all sink after a little bit, which, I don't know, I got hope. If you do 13 in here, how many do I really need? 10. So I'm okay because I can just pull out the extra ones if I know that 10 have sunk. Does that make sense to you? So maybe I don't need to go again. But if I did want to go again, I would just then suck up a little more water. I would make sure that I got all the air out. I would again put my thumb here, pull back. While I'm pulling back, I'm shimmy, shimmy, Cocoa Puff. That probably works. Okay. And then I just sit here and tap. When I've got both of these good, when I have both of them so that they sunk, now I'm ready to move forward in the lab. So this is what you want to do. You want to have your light, and don't put the light over your cabinets like these people did. Put it on the center ones and out and away, because these cabinets you may want to get in and out of, and these will stay shut, right? Because these are my cabinets, there's nothing in here for you. These lights normally go underneath here. So you're going to want to let them sit and cool, so you don't need to put them away, but that's where they came from, is under here. Now, I had to replace a couple light bulbs, and I want to tell you, the round standard light bulbs, I think work better than these spirally ones. So if you want to, you can huddle around just the good smooth bulbs and not the spirally ones. I don't know if they're generating enough energy, those spirally ones. Do you see how we're introducing another variable by having two different light bulbs? So as a result of that, I would just share with the other team and set up a little station. Now, the other thing you're going to want to do is get the largest beaker you have in your sink, and you want to take that water, and when you do your experiment, this one would be full of water and disc too. You want to have this here so it absorbs, the water acts as a heat sink, and it absorbs the heat, so you don't end up making that a variable nor cooking your leaves, okay? Because it's not wilted spinach lab, okay? And so, again, when I look at this, it would look like maybe they wouldn't go down, but if you give them a tap, tap, and just let them sit, now lesser sinking. Yeah, give them just a tap, tap, and let them sit. They should hopefully then sink, which they are doing. Did you see that they're doing that? Okay, then what I do is I go over to the cup that I got the solution out of, and I just put that water right back in there. Are you going to be short a few milliliters of water? Probably. It's okay. All right. Get your Starbucks stick that I put in there, if any get stuck in there, and use that to get them out. Now, as I'm looking, did all of them sink? Yeah. Booyah. Okay. So now I would take this one and my other one, and I would put it here, time 0, start my time, okay? Now, when you take your first measurement, do not stop the clock. Time moves forward, okay? Just take your reading at 2 minutes while the clock's still running, and then take your reading at 2 minutes again. And if you're gonna count them, probably the one without CO2 isn't going to float. I'd be really interested if it is. Tell me, because I can you have to let them go a really long time to get one of those to float. And you want to max out at 20 minutes, okay? And just go through and then record it every 2 minutes. When you're done, you're going to clean and dry everything and put it away, except this stop box right here, okay? You can leave it at the station right for now, because some people might want to come in and lunch, or they might want to repeat the lab or go again. While you're working on the lab, you're going to stack your lab notebooks up to the front page of your lab. By the time I get to you, I'll start here and I'll be working around the room. Have it be rubric, lab notebook, rubric, lab notebook. Okay, I'm not quite done. I'll show you a couple more things. You can ask me questions. Okay, so it'll look like this. Dump them at the same time. Put them underneath the light, and then start to count as they float up. What else is in here? Oh, that's what they look like. We already talked about this. Do not, if you're going to do your variable, if you want to do 3% baking soda, that's fine. It's totally up to you. You know how to calculate it. I wouldn't go over 4%, because the baking soda itself is what we estimated last year when we had different students try this. The baking soda itself became heavy inside the leaf and wouldn't allow it to float, even though it had the air. It was counteracted by how dense the baking soda solution was. Does that make sense? But we didn't know that till last year when some kids went over 4%. You're going to do your data table and time. When you go to graph this, right, you're going to graph your minutes right here on your x-axis, and then number of floating leaf. ET50, what is the ET50? That's the time at which what? Half of them floated, okay? So, and then you want to have quality work, which I'll be talking about as I see your setups. Okay, so let me answer some questions. Go ahead. Yes.
So if you have in the syringe like more than 10 floating, do you still put all of them, sinking, do you still put all of them in there?
You can leave all of them in there, but just count the first 10, or you can go ahead and remove those 3 if you want to. Yeah, but if you go with 13, 12 or 13, you're more likely to get 10 that sink. Yes?
You said it was 20 minutes, but then on our data table.
I know, 20 minutes is probably safer. You might get them all floating by 15, but you might want to go ahead. Okay, what else? Okay, and so I don't need to repeat myself because I had to do this for a few groups. It looks nicer on your lab, but a couple things this is what I point out is maybe errors, not errors, okay, just so it looks nice. Put driving question and then underline it and then say it, right? Hypothesis, underline it so it pops, you know? Make it neat, make sure there's spacing between each section. Your picture should be simple, right? 1 cup, input, output, simplified instructions, constant, control, right? And then when it says calculations, that's not where you do your calculations. You just tell me what equations you would be using in here. That's what goes on your flow chart. Because all calculations always go underneath your data table. Those data table calculations, and then the calculations that you need for your analysis. Is this lab due next class? No. If you look on your calendar, it's not due till the class after that. So if you have questions, you want to be ready with those questions when? Next class, so you can ask me. Okay? Not emails on Sunday night because it's due on Monday, right? So do you remember all the reference material I have in your HyperDoc on your lab map?
Yes.
Those are all there for you to help you. You have a rubric. Don't lose this rubric. My signature is going on it saying I saw your pre-lab. If you lose it, you lose 10 points right off the top. Okay? Now, look around the room. We have 32, 33, 34, 35, right? People in this class. 8 times 4 is what? 32. So I can have 3 groups of 5. 3 groups of 5. So I'm betting you 3 are probably going to have 2 more, which will make you a group of 5. Are you guys working together or are you working with somebody else? I don't care.
Probably not.
Somebody working else. Okay. So I can have 3 groups of 5 and that's it. Do I know who my groups of 5 are right now? So we establish that? Okay, so don't make over 3 groups of 5. Okay, I'll look around when we do that. Any other questions or concerns? Okay, head to a lab station.
Can I get my
Make good choices.